Hi guys, welcome back to Python based data science series. In today's session, we'll be discussing about inheritance. In earlier session, we discussed about class, objects, how to perform encapsulation. While constructing class, a main feature we implement that is called as constructor. Constructors as well as destructors are the main key features of class. Let us firstly understand constructors as well as destructors before going for the implementation of inheritance. Constructors in Python. Constructors are generally used for instantiating an object. The task of constructor is to initialize, assign values to the data members of the class when an object of the class is created in Python. The init method is called the constructor and is always called when an object is created. Syntax of constructor declaration: def, init and self. And then we have to define the body of constructor. Here self is referencing to an instance or an object which we are constructing. There are two types of constructors. One is default constructor. The default constructor is a simple constructor which doesn't accept any argument. Its definition has only one argument, which is a reference to the instance being constructed. Then we have a parameterized constructor. Constructor with parameters is known as parameterized constructor. The parameterized constructor takes the first argument as a reference to the instance being constructed, known as self, and the rest of the arguments are provided by the parameter. If we are not passing it on any argument at the time of creating instance, then default constructor will get a call. While constructing an instance, if we are passing on number of arguments, then we need a parameterized constructor. We need to understand one point. Every constructor requires self as an argument, because self pointing to, referring to an instance we are constructing. What is destructor in Python? Destructors are called when an object gets destroyed. It is having a reverse definition of constructor. Constructor constructs an instance, destructor destroys it. In Python, destructors are not needed as much needed in C++ because Python is a garbage collector. Garbage collector means unreferred, unused objects will put into the garbage automatically. That technique is called as garbage collection. That handles the memory management automatically. The del method is known as a destructor method in Python. It is called when the references to the object has been deleted. That is, when an object is garbage collected. Syntax of destructor declarations: del, definition, self, and body of the destructor. A reference of object is also deleted when the object goes out of reference or when the program ends. Means we can explicitly delete an object by using del keyword, but at the same time, at the end of a program, automatically the created object objects and instances are going to delete. The references of objects as well as the memory allocated will be destroyed. Then we'll be discussing about inheritance in Python. Inheritance is the capability of one class to derive or inherit the properties of another class from another class. The benefits of inheritance are: it represents real world relationship well, it provides reusability of a code, we don't have to write the same code again and again. Also, it allows us to add more features to the class without modifying it. It is transitive in nature, which means that if class B inherits from class A, then all the subclasses of B would automatically inherit it from class A. The main striking feature before implementing inheritance is reusability. We need to establish a relationship between two classes by setting it up as a base class and a derived class. Due to this relationship, the instance of derived can refer to its own properties and behaviors, as well as it can refer to the properties and behaviors belongs to base. In this manner, reusability can be achieved. There are many types of inheritance. Multiple inheritance: when derived class is derived from more than one source, then it becomes multiple inheritance. Multi-level inheritance: when there is a link from one base, a derive can be formed, and from that derive can become a base of some other. In this manner, if we just establish a link of A to B to C to D sort of, it become a multi-level inheritance. Let us discuss all the things practically. As we just discussed conceptually, constructors are of two types: default and parameterized, and used for initializing the values belongs to class. Here, I am constructing a class called as facto. Here is definition of default constructor: def init self.n equals to 3. Means whenever an instance of facto class will be created, the default number property will initialize by 3. Here I am commenting a multi-line comment for parameterized constructor. Need to understand one thing: you should have only one constructor at a time present in a class. So I am commenting this parameterized constructor. Now then, we have a definition called as find facto. This find facto is actually defined for finding factorial of a given number. So f equals to 1 while self.n more than 0, because factorial means it holds the multiples of a number till it reduces from n to 1. While self.n more than 0, f into equals to self.n and self.n minus equals to 1. It reduces the value of n by 1 and hold the multiplications and return the final factorial. I'm explaining a role of a default constructor. A constructor which have no arguments. In main, f equals to factor. I am creating an instance by the name of f, and there is no arguments passed on at the time of creating. So it gives a call to default constructor. Self is referring to an instance we are creating, and the value of number become 3. Hence, whenever you find the factorial of a number, you will get the factorial of a 3. Let us execute it. Here you will get the factorial of 3 by default. But now you want to use the same code, but not by the default value, but user want to provide its own values. Let's make a comment to default constructor now. Here, parameterized constructor is available for accepting an extra argument from the user. Means by that argument we can initialize the number, and then we can find the factorial of it. Now here n equals to input a number. User will input a number and it will be assigned to n. And then by that user input we are creating an instance of factor. Now user input will be initializing the number, and then we can able to find out the factorial of user input. In earlier case, it was a call to a default constructor, but in this case it gives a call to the parameterized constructor, and hence user can able to customize and factorial of a user defined number. Let's test the execution. Here it is prompting user to enter a number. If I enter 5, it should give me the answer 120. Here it is. Means you can define the constructor without an argument, and that is called as default constructor. In that case, the property belong to class will get initialized with the default values. In case of parameterized constructor, user will pass on user defined arguments, and by which the properties of class can be initialized. This is the role of default and parameterized constructor. Let us discuss a role of destructor. As discussed, destructor is having a reverse definition of constructor. It is useful for deleting, destroying, and created object. Here, in class employee, we are having a constructor which is creating an instance, and here is a destructor which is going to delete that created object. Object equals to employee. Object become, and it gives a call to the default constructor, and object is created. And if you call to destructor, the created object is going to delete. Means constructor constructs an object and destructor destroys it. Let's test it. Employee created, destructor called, employee deleted. As discussed, destructor don't have any arguments. It cannot be parameterized. Its role is to delete, destroy an exist object. Python itself takes care of garbage collection. At the end of a program execution, it destroys, deleted all the references of object. But if we want to define a destructor, we can. And if we want to call a destructor, we can. Here it is another example. We have a class employee. Here it's a default constructor. Here it's a destructor definition. There is a method called as create object, which is creating object and then returning object. And then here we are object equal to create object, means we are giving call to the function called as create object. So it will print firstly making object and give a call to the constructor of employee. So in this manner it will creates an instance of employee and function ends and return that object. Means at the time of object creation, instead of directly giving call to the constructor, we give a call to the function called as create object. It will create an instance by giving call to the default constructor and return that object, and that value will be assigned to object. And when the program ends, here when the program ends, automatically it gives a call to the destructor and delete that all the references of object created. It means there is no need to give a call to the destructor explicitly, because at the end all the objects created are going to delete. But if you need to give a call explicitly in the mid of program executions, you can. At the end, everything is going to delete, everything is going to destroy. But in the mid, if you want to delete unreferred, unused objects, you can. That is the role of a destructor. I'm having another example to demonstrate destructor. So I'll make this top program comment. Okay. Here is class A. It is having its own constructor, and it needs an argument by which the property of a class will be initialized. Class B having a default constructor, and it is referring internally to the constructor of a class A. Means B is linked with A. And then there is a definition of destructor, which is going to print die. And there is a function called as fun, which is giving call to the default constructor of B. Just understand this nesting. Now we have a class A having parameterized constructor, we have a class B having default constructor and the destructor defined in class B. A function B is going to create an instance of B. Let's give a call to the function. If you give a call to the function, it is going to refer to the default constructor of B. Default constructor of B is referring to the constructor of A, and then the value of B is going to initialize, and then it is going to give a call to the destructor automatically. Let us check how the execution will be. Yeah, it is going to print die. But how it give a call? Firstly, it refers to B. B is referring to A, right? Here we pass on its own reference, and by which we can initialize the values. Ultimately, we can pass on some values if needed, because A is having a parameterized constructor, and by that the value of B will be initialized. So A, and then that value will be initialized to the A, and then you can give a call to the destructor. This code is going to explain us how we can nest the call. A function is referring to B, and the constructor of a B is referring to the constructor of A, and then whichever the object we are constructing an object of B. At the end, it is going to destroy the references of A as well as B. We are not creating an instance of A, we are creating instance of B, but as it is referred from B, the instance of A, instance of B will be generated, and at the end, destructor is going to destroy all references. Now, let us go for demonstration of inheritance. We understand the concept well of constructor and the destructor. Inheritance, as it is useful for reusability, we should have a base class and a derived class. It should be the relationship between the two classes. We are having a class person. If while defining the class, if you have an object reference, it means it is a root class. It is not extended from any other. It's a base class. So class person having a reference of object, there is an object class available in Python. In inheritance, if a class is referring to object, it means it is a base class. Class person having a constructor which is accepting name as a parameter and initializing its own property. Then we have a getName method which is returning the name. We have a isEmployee method which is returning false. Means there is a person class having a parameterized constructor, getName, and isEmployee method. Class employee is extending from person. There is a relationship between person class and employee. If as an argument, person class having argument of object means it is not extending from any other class, it is a root class. Class employee is actually extending from person, means person is a base class of employee. In employee class, there is a method definition, that is isEmployee, and return true. Now, emp equals to person abc. We are creating an instance of person class. So it gives a call to the parameterized constructor of person class, and the name abc will be passed on. Emp become an object. Emp.getName will refer the method of getName belong to person class and return the name of it. Emp.isEmployee is a method belong to person class and it return false. So it will print abc false. Now emp object we are creating by referring to parameterized constructor belong to employee. Hence top emp is referring to person and this emp referring to employee. Now employee, and we are passing it on the parameter, that is the name of employee. Employee class don't have its own constructor, but as it is inherited from person, whenever you create an instance of employee, it gives a call to the constructor of person, and the name which you pass on, PQR, will be initialized. So here in this case, emp.getName, there is no method getName in employee class. As I said, it is extending from person, so it gives a call to the method belong to getName. So it will print PQR. But there is a method definition is employee available in employee as well as in person. But EMP is actually referring to employee class, so it will invoke its own method. So this time it will return true. Need to understand the execution. There is a relationship between two classes, person and employee. Person is a root class and employee is a class derived from person. Person class having its own parameterized constructor and getName and isEmployee method definitions. Employee class having only one method definition, that is called isEmployee. A person, whenever you create an instance of person, if you print the name and isEmployee, it is referring to its own methods and prints ABC false, because isEmployee is returning false in case of person class. In case of employee class, though it don't have a parameterized constructor, at the time of creating instance, it refers to the constructor belongs to root and initialize the name. So emp.getName, this method is not belong to employee, but being an object of derived class, it can refer to the methods belong to base. So emp.getName will print PQR. emp.isEmployee, now it will not refer to the method of base class because it is having its own method. In case of inheritance, the priority of method executions goes to itself first. If the method is available in its own definitions, it executes firstly. If it is not available, then the call goes to the base one. Here is employee having two method definitions. One is own, belongs to employee class, and one is belongs to the person class. The object of employee referring to its own method, so it will give a call to itself. So it will print PQR true. Let us test it by execution. ABC false, PQR true. Means in case of EMP, it is referring to person class. Person class having EMP is employee method which returning false, but EMP now referring to employee class. While constructing it as initialize getName, name with PQR, and getName will return you the PQR, but isEmployee is its own method. In this manner, we can establish the relationship between the two classes and invoke the method. Let us discuss this by another example. We have a class person. It is object reference, means it is a root class. There is a parameterized constructor which is having two parameters, name and ID number, and by these parameters its properties will be initialized. Then there is a display method which is having name and ID number will be displayed. Person class, which is a base class, having parameterized constructor and display method. Employee class is extending from person. It is having a parameterized constructor and having four arguments, name, ID number, salary and post. By the argument salary and post, it is going to initialize its own properties. Now, at the time of creating instance of employee, it is accepting four arguments, name, ID number, salary, post. Salary and post will be initialized to its own properties, and inside of its constructor it is giving call to the constructor of a base class. Person.init means it refers to the constructor belongs to person class. In earlier example, without giving call to the constructor of base, whenever you create the object emp employee and pass on the argument, it directly give a call to the constructor of a base. But here in this case, we are explicitly referring the constructor of person class by passing it on number and ID number. So this extra argument name and ID number will be passed on to the constructor of a base class, and the name and ID number will be initialized. Here we are creating an object of employee class. Employee class having 4 arguments. So we pass on name Rahul, this ID number 886012, its salary and the post. Salary and the post will be initialized to employee properties, and to the constructor of base the name and ID number will be passed on. If you give a call to the display method, now display method is not available in the employee. So if you give a call to the display method, it display Rahul's name and the ID number. It proves a point that we can even able to call the constructor of the base class explicitly and give a call to the method. Because of relationship between the base and derive, the object of derive can refer to the constructor as well as methods, and the properties belongs to base. It proves inheritance. Let us run this. Here it is. The display method, which is not a definition of employee class, but due to inheritance it gives a call to. Though we are not creating an instance of person, it is referred internally from the derived class. And in this manner, we can reuse the code which is available in the base class. As we discussed, inheritance also having various types. Multiple inheritance, at the same time multi-level inheritance. Let us discuss an example of a multiple inheritance. Multiple inheritance means if we have more than one base source while inheriting, then that is multiple inheritance. The programming language of like Java won't support multiple inheritance, but in Python we can able to perform multiple inheritance as well. We have a class base1. It's a root class and having its own constructor, default constructor, and it's initializing with the string value with the axiom, and it will print base1. This is base1. Now base2 also a root class. Root class means it is not extended from any other class, and it is initializing the string with the tag guru, and it prints base2. Now class derived is extending from base1 comma base2. As derived class is extending from more than one source, we are implementing multiple inheritance. Here it is a definition of default constructor, and then we refer the constructor belongs to base, constructor belongs to default, constructor belongs to base, default constructor belongs to base 2, base 1, base 2, and then print direct. Here is the method definition print strs, and it will print the value of str1 and str2. In the default constructor of base1, we are initializing str1 to the axiom and str to the tech group. We are going to create an instance of derived. Whenever you create an instance, it gives a call to the default constructor and initialize the base1 and base2 properties. And whenever you print strings, it will print axiom, tech group, and derived. Let's go for the execution. Base1, base2, derived, and axiom tech group. Means whenever you give a call to the default constructor of derived, here it gives a call to the default constructor of base. It initializes str1 to axiom and print base1. Then it will initialize the string of base2 with the tech guru and print base2. So base1, base2, it print derived, and then it gives a call to the print strs and prints axiom tech guru, and hence the result base1, base2, derived, axiom tech guru. It proves that how we can extend a derived class from more than one source. Let us discuss one example of a multi-level inheritance. Multi-level means though a derived class is extended from one, but there is another extension. Up till now, we extend a class from either a root or from multiple source. But that derived class also extended further, then it become an example of multi-level inheritance. Class base, root class, it is having default parameterized constructor. Then it returns the get name, returns the property of it. There is a child class which is extending from base. It is also having parameterized constructor and child class referring to its base class and initializing its own property as well. And there is a method called as getAge. There is a grandchild class which is extended from child. Base class is a root class, child class is extending from base, and grandchild class is extending from child. In this manner, it proves multi-level inheritance. Here is the parameterized constructor of grandchild class, which is accepting arguments of name, age, and address. Grandchild class is actually extended from child, so it gives a call to the constructor of child class and pass on name and age. Address argument will be assigned to itself, means address is a property of grandchild, name and age is a property of child class, name will be passed on to base and age will be initialized to itself, means address is a property belongs to grandchild, age is a property belongs to child, and name is a property belongs to base. In base class we have a get name, in child class we have a get age, and in grandchild class we have a get address. We are going to create an instance of object, instance of grandchild, g equals to grandchild, axiom take guru 25 Nagpur. Now this name will be passed on to base, age will be passed on to child, and address will be passed on to grandchild. As this grandchild class is not actually extended from base, but till the base class of grandchild is extending from base, it can refer to the properties and methods belongs to the base class also. G dot get name. Get name is a method belong to base, but the object of grandchild can refer it, though it is not directly inherited from base. Get age also, get age it gives a call to, it is not a method belong to grandchild, but it's a method belongs to the child class it can refer to, and get address it is having its own method. Let us go for execution. Axiom take guru 25 Nagpur. It proves the point that we can able to perform multi-level inheritance, a base class, a derived class, and another derived class, grandchild, which is extended from derived. Let us discuss how we can check which class is a subclass of another class by using a predefined method called as is subclass. Here it's class base, it's a root class, and it's empty class, so empty class can be defined by the keyword pass. So class derived actually extended from base, and it's also empty class. But there is a relationship between base class and derived class. Base class is not extended from any other class, but derived class is extended from base. We are using the method called as is subclass. Derived base is derived is subclass of base, so the answer is true. So it will print true over here. Is subclass base derived? If is a base is subclass of derived, so the answer is false. Then D equal to derived. To check the relationship between the two classes, we can use this is subclass method. D is an instance of derived. B is an instance of base. Now, there is another method called as is instance. Is B is a instance of derived? Actually, B is not an instance of derived. D is an instance of derived. So it will print false. But is instance D of base? Actually, D is not an instance of base. But here in this case, it will print true because the object of derived can even able to give a call to the base. Here D equal to derived, the object of derived, and B equal to base. Now B is an instance of derived. Actually, base class object cannot refer to the derived class, but the derived class object can refer to the base class. So the answer we are expecting is subclass. Derived is a subclass of base, true. Base is subclass of derived, false. Then this is the use of is subclass method. There is a to check whether the given instance is the instance of specific class. There is is instance method. So here B is the instance of derived, false. D is the instance of base, though it is not directly, but due to inheritance it will print true. Let's check it out. Here it is, true, false, false, true.